Hello my dear student of FYBSc class, welcome you again. In this lecture, we are going to see again some number of problems regarding to elasticity. Now, the first problem in this lecture is a wire of 0.5, that is in meter, and 1 square millimeter in cross section has Young's modulus 1.24 into 10 raised to 11 Newton per meter square. Okay. Now, how much work is done in stretching the wire through 1 millimeter? Suppose this is a rigid support or ceiling and this is a wire. Okay. The length of this wire is 0.5 meter and area of cross section of this wire is 1 square millimeter. Okay. And Young's modulus of the material of the wire is Y. Then here what we have to do or what we are going to obtain? We are going to obtain the work done in stretching the wire through 1 millimeter. Have you got it? Okay. So, the solution of this problem is solution given, and in given the first quantity is L is equal to 0.5 meter. Okay. Then L, that means extension of the wire. This is nothing but 1 millimeter. Then next quantity is area of cross section. A is equal to 1 square millimeter and Young's modulus is equal to 1.24 into 10 raised to 11 Newton per meter square. Okay. Now, before solving this problem, we should have to convert all the units in a single, or we have to the uniform units. That means here most of the units are given in, 2 of them is in SI and 1 is other than SI. So, we are going to convert in SI. So, conversion of 1 millimeter into meter is nothing but 10 raised to minus 3 meter. Okay. Now, conversion of 1 square millimeter into meter is equal to 10 raised to minus 6 meter. Okay. This is the given in the problem. Now, in order to obtain the work done, we have the formula work done is equal to, what is the formula for work done? 1/2 into what? YA upon L into L square. This formula is already studied by us during the theoretical aspects. So, substitute the value of each and every term 1/2 into Y 1.24 into 10 raised to 11 into area of cross section is 10 raised to minus 6 upon value of L is 0.5 into value of L square is 10 raised to minus 3 bracket square. Okay. Now, when you are going to solve this problem, I think there is need not necessary to use a calculator, because 2 into 0.5 is nothing but 1. Okay. So, again 2 into 0.5 is nothing but 1, and here we have 1.24 into 10 raised to 11 into 10 raised to minus 6 into 10 raised to minus 6 here. 10 raised to 11, 10 raised to minus 6 and 2 minus 3 minus 6. So, and this into this 0.5 into 2 is 1. Therefore, 1.24 into 10 raised to minus 6 minus 6 minus 12 plus 11, that is minus 1. So, 0.124 joule is the unit, and this is the work done in order to stretch the wire whose length is 0.5 meter, whose in order to stretch the wire so that it forms the elongation, that is 10 to minus 3, area of the wire is 1 square meter and Young's modulus of the material is 1.24 into 10 to 11 Newton per meter square. In this way, we obtain the answer. See here, everything is very simple. Please don't afraid to problems. Okay. Now, we are going to see the second problem. In second problem, again a steel wire having length 2 meter. In problem, there is a steel wire whose length is 2 meter and radius is 1 millimeter radius, and this wire is stretched to millimeter. Radius of the wire is equal to 1 millimeter, and this wire is stretched so that there is extension of 0.5 millimeter. Okay. Now, find the energy stored per unit volume of the wire and work done in stretching the wire, whereas Young's modulus of the steel is again 2 into Young's modulus of steel is equal to 2 into 10 raised to 11 Newton per meter square, and L is 0.5 millimeter. See, again try to understand the problem. You are having a wire whose length is 2 meter, radius of cross section of the wire is 1 millimeter, and here we stretch the wire so that elongation or the wire is extended by 0.5 millimeter. Now, here we want to find out the work done, energy stored. Work done means energy stored per unit volume of the wire. Okay. So, this is the given. Again, convert some quantity. Suppose this is 10 raised to minus 3 meter. L is again 0.5 into 10 raised to minus 3 meter. Okay. Because unit should be uniform, either in SI or either in CGS. Okay. These are the given quantity. Now, we are going to calculate first energy stored in the wire per unit volume, and secondly we are going to obtain the work done in stretching the wire. Okay. So, first energy stored per unit volume of the wire. So, for this purpose formula is very simple. This is also studied by us in theoretical aspects, is equal to 1/2 U by V. U is the energy and V is the volume. So, energy per unit volume 1/2 Y into L square into L. This is L length square and this is L. Okay. Now, substitute value of each and every quantity 1/2 into Y, 2 into 10 raised to 11 upon L square, that is 2 square into L 0.5 into 10 raised to minus 3. Okay. This is the formula. When you solve this by using simply calculator, you will get the answer, that is energy stored in the wire per unit volume is nothing but 6.25 is the calculation obtained into 10 raised to 3. And what is the unit of energy? That is joule per meter cube. Why meter cube? Because energy stored per unit volume, and volume is the cubic quantity. Okay. Now, the second quantity, that is work done. First we obtain the energy per unit volume. Now second quantity is work done. Work done is stretching the wire so that it elongates by an amount 0.5 millimeter. So work done, W is equal to 1/2 again into formula Y upon A by L square. This formula is also studied by you, L into L square, same formula. Okay. Only here area is given. Okay. Now here area of the wire is nothing, wire is cylindrical. So we have 1/2 Y pi r square upon L into L square, because here radius is given. Okay. Now substitute the value of each and every term. 1/2 Y into 2 into 10 raised to 11 into 3.142 into radius 10 raised to minus 3 square upon L, that is 2. Again solve this, we will get 2 into 2 get cancelled and only 1/2 of this. When you solve this problem, sorry, one more quantity is there, length square, that is 0.5 into 10 raised to minus 3 square. So solve this, this is the value of L, and solve this, we will get the answer very simple. Only use calculator, we will get 0.0393. What is the unit of work done is joule. In this way we obtained energy stored per unit volume and work done of the wire. Now third problem. Third problem is also, again there is a wire, and suppose this wire is, one end of the wire is fixed to ceiling or this is support, and when we suspended the wire from the free end by applying some load, and this load is increased from 1 kg to 6 kg. When we apply the load 1 kg, then elongation of the wire is produced by, elongation in the wire is produced by 0.5 mm. And when we apply the load by 6 kg, then elongation is produced by 3 mm. Okay. And now in this wire we have to find out the work done during, work done for the extension. प्रॉब्लेम समजून घ्या. एक वायर तुम्हाला दिलेली आहे आणि या वायरला, या वायरचं एक टोक आपण सिलिंगला फिट केलेलं आहे, दुसऱ्या वायर टोक फ्री एंडला काय करतो आपण वेट अप्लाय करतो. आणि वेट कसं अप्लाय करतो 1 kg टू 6 kg. जेव्हा आपण 1 kg वेट अप्लाय करू त्यावेळेस वायरचं इलॉंगेशन होणार आहे, वायरचं जे स्ट्रेन आपल्याला पाहायला मिळेल तो असणार 0.5 mm. आणि जेव्हा आपण लोड आपण 6 kg अप्लाय करू ॲट दॅट टाइम एक्सटेंशन इन द वायर हे असणार आहे 3 mm. ओके. आणि इथं आपल्याला वर्कआउट कॅल्क्युलेट करायचं आहे. सो here solution. Here when wire is stretched a distance L by a force, comma, the work done is nothing but W is equal to 1/2 FL, where we are going to apply the force and elongation of the wire takes place. Okay. When force is increased by from F1, suppose here F1 is given 1 kg weight and F2 is 6 kg weight, and elongation wire, that is L1 is 0.5 mm and L2 is what, 3 mm. Okay. So the extension increases from 0.5 to 3 mm, 0.5 mm to 3 mm when we apply the load from 1 kg weight to 6 kg weight. Now here work done, very simple problem. Work done is equal to again 1/2 F2 L2 minus 1/2 F1 L1, or simply 1/2 F2 L2 minus F1 L1. So very simple problem. Substitute the value of F1 F2 and L1 L2. F1 is 6, L2 is 3, okay, but in weight, so we have to multiply it by 9.8, okay, and 9.8 into 3 into 10 raised to what, again 10 raised to minus 3 meter. Here 0.5 into 10 raised to 3 meter. Okay. Now minus 3 minus value of F1 is 1 kg into 9.8 into extension is 0.5 into 10 raised to minus 3. Okay. Now when you solve this, you will get 1/2 in bracket 9.8 into 17.5 into 10 raised to minus 3. Okay, again solve this, you will get the answer 0.9585 joule. Sorry, calculation 8575 joule. In this way, we can obtain the work done by very simple method. Now, the next problem, these are the problems related to Young's modulus, bulk modulus and modulus of rigidity. Now, again there is a steel wire and this wire is fixed to rigid support. The length of the wire is 4 meter. Length of the wire is 4 meter and is acted upon by the force, that is 10 Newton. We apply the load of 10 Newton. Calculate the certain strain produced in the wire if energy stored in the wire. Energy stored in the wire is 2.2 into 10 raised to 11, 10 raised to minus 3 joule. This is the energy stored in the wire and length of the wire is 4 meter and strain, that is force, is nothing but 10 Newton. These are the given quantity. I am again going to repeat the problem. There is a steel wire whose one end is attached to ceiling or fixed to ceiling and a load of 10 Newton is applied to its free end. The length of the wire is 4 meter, and when we stretch the wire by a certain strain, at that time energy stored in the wire is given. Okay. Now we have to calculate the certain strain. So given L is equal to 4 meter, again force or load is 10 Newton and energy stored in the wire is 2.2 into 10 to minus 3 joule. Okay. Now we know that very simple formula. We studied this formula in theoretical aspect, that is energy stored is equal to 1/2 into stress, okay, so, load into extension. So, energy stored is 2.2 into 10 raised to minus 3 is equal to 1/2. Load is 10 and we are going to calculate extension, that is strain. So, suppose extension is L, then okay, simply 2 by 10 by 2 is nothing but 5. So, 2.2 into 10 raised to minus 3 upon 5 is equal to L. When you calculate this, okay, you get the L is equal to 4.4 into 10 raised to minus 4 meter. Okay, and strain, we know that strain is nothing but equal to small l upon capital L. That is original change in length divided by original length. So, change in length is 4.4 into 10 raised to minus 4 and length, original length is 4. So, we get 1.1 into 10 raised to minus 4. What is the unit of strain? Strain is unitless quantity because this L is L and change in length and change in length measured in same unit. Okay. Now, one more problem. See one more problem. Find the energy stored per unit volume of a copper wire of uniform cross sectional area and the length 1.5 mm. Here again solution given L is equal to what I say 1.5 meter. When wire is stretched to a length, that is L is equal to 0.5 sorry 1.51 meter. Okay. Now, stress in the wire is, stress is also given, stress is the stress and that stress is nothing but 3 into 10 raised to 12 sorry 2 Newton per meter square or Newton meter raised to minus 10. Okay. See here again same way. There is a wire fitted to ceiling. The wire length of the wire is 1.5 meter. 1.5 meter. When we apply some load, then the wire is, after application of the wire, this is the original length, and when we apply the load, then elongation of the wire takes place and final length of the wire is 1.51. This is initial and this is final and stress is given. Okay. Now, in order to find out the energy stored per unit volume, what we have to do? First of all, we have to calculate strain. Strain is equal to, what is strain? Change in length per unit original length. Okay. Before this, see here, length is L is 1.5 meter and after extension this is, therefore L, that is small l, change in length. What is the change in length? Original length is 1.5 and after applying the strain, the final length is 1.51. Therefore, 1.51 minus 1.5, you will get the answer 0.01 meter. This is the change in length. Okay, this is the stress. So, strain is equal to small l upon capital N. that is change in length per unit original length. What is the change in length? 0.01 upon 1.5. This is the, or simply you can write 1, move 2 digits and 150. Okay, these digits take to this point, that is we are going to shift 2 digits. So instead of 0.01 we can write 01, that is 2 digits shifted, and 1.5, when 2 digits shifted we get 150. This is the strain. Okay. Now the energy stored per unit volume, is, what is the formula for this? I know very well. I am simplify this formula in the theoretical aspects. 1/2 stress into strain. 1/2. What is stress? Stress is given here. What is stress? 3 into 10 raised to 2. And what is strain? This one, 1/50. So here also there is not necessary to use calculator, only simply 3 divided by that is 3. So we have what? Sorry, 50. 3 divided by 150, that is we will get 50, and 150, sorry, 50 into 2, that is 100. So 10 raised to 2 upon 100, that is nothing but 100 divided by 100 is equal to 1 joule. This is the final answer of the problem. Again I am going to repeat the problem. We are having a wire, one end of the wire is fixed to rigid support and some load, certain load is applied to its free end. The wire length of the original length of the wire is 1.5 meter, and when we apply certain load, then extension of the wire takes place and we get the final length of the wire. So change in wire, so the final change or final length minus initial length, we get the change in length and original length of the wire. So from these two quantity we can obtain the strain, and after getting the strain we can calculate the energy stored per unit volume, and formula for that is 1/2 stress into strain. Simply put up the value of stress and strain, you will get the answer 1 joule. Okay, all these problems are related to modulus of elasticity. In this way we see the problems related to Poisson's ratio. Friends, there are many more problems, but all that problems I will provide you in PDF notes when I am going to supply the PDF note to you. At that time you have to solve that problems. Some of the problem will be solved and some unsolved problems are there for your homework. You just try to solve them. I hope that you can solve every problem. If you are having any doubt or if you are having any query, then contact me. I can solve your difficulty. Till then we shall stop here. Have a good day. Thank you.